What up, guys? So today we're going to do this physics paper, October, November 42. Okay, let's look at the first question. State the difference between scalar and vector quantity. Oh my god, so easy. Even my grandma also can do this. So, scalar only has magnitude. Okay, but vector has both magnitude and direction. Easy peasy. Number 2, in the list, underline each quantity that's scalar. So out of all these examples, the scalar quantity here we have is mass, energy, and temperature. Okay, B. A tennis player throws a tennis ball into the air, blah blah blah. Show the initial velocity tennis ball is 9.9 upwards. Okay, so how we do this? You can see here they told you the ball reached a maximum height of 5 meters. Okay, so this maximum height is like the ball has this GPE, gravitational potential energy. Okay, so it's basically the conversion between the energy from KE to GPE. Okay, so we have this formula, KE equals GPE, kinetic equals gravitational potential energy. So formula half mv squared equals mgh. Okay, so we can cross out the m here. So half v squared equals g 9.8 times the height 5 meters. Okay, so we arrange everything, you solve your v, and you should get around 9.9 meters per second. Done! Number 2, calculate the momentum of the tennis ball as it leaves the tennis player's hand. Okay, so momentum, P equals mv. So the mass, 5.8 times 10 power of negative 2, times the velocity, 9.9, and you should get a final answer, 0.57 kg meter per second. Oh my god, so close. So close to 6-7. Anyway, question number 2. A truck moves with constant acceleration. The speed of truck increased from 13 to 22. Time taken, blah blah blah. Resultant force. So force formula, F is equals to ma. Okay, but we don't have the acceleration here. So how we find the acceleration? A equals v minus u over t. Okay, so here the final velocity is 22 minus initial 13 over the time taken 4.5 seconds. So 22 minus 13 divided by 4.5, we get 2 meters per second squared. Okay, and we go back here, F equals to ma, so 3,700 acceleration 2, and we should get answer 7,400 Newton. Done! Number 2, the engine of truck provides for force, state 2 forces acting in opposite direction. So easy! So the first one, air resistance. Okay, so the second one you can say friction. Okay, the friction between the tire and the road. Mamma mia! Okay, B, circular motion. Draw arrow to show direction of force. Okay, everyone, if you have a circular motion, your resultant force is a wave acting towards the center of the circle. So this is your F. Done. Number 2, a different car travels around the same track. State 2 possible reasons cause the car to slide off. Ooh. So what will cause the car to slide off from a track? Common sense, bruh. First one, the car has higher speed. Okay, this is going too fast, so it slide off. Second, okay, maybe the tire is not that good. It has lesser friction to grip the car on the road. Okay, so easy. Now we look at number 3. Solar panels, blah blah blah, efficiency 16%. One advantage of using black solar panels. So why we always use black color? Because black is good heat absorber. Okay, so we just mentioned it's a good absorber. And then okay, what's the advantage on this? Okay, why we need a good absorber? So more electricity can be generated. Done. B. Calculate the power received by solar panels from the sun. Okay, so here they have the output power and we have the efficiency. So we need to use the efficiency formula. Output power divided input power times 100%. So my output power is 3,500 watts over the input, and my efficiency is 16. Okay, so just rearrange this. The input power we get should be 22,000 watts. Hell yeah, so easy. Question C. The solar panel produces direct current and households use AC. See the difference between AC and DC. Okay guys, so what's AC, what's DC? Okay, so DC is basically like your battery. They provide the same amount of voltage throughout the time. Like for example 5 volt, okay, constantly 5 volt. So for AC, what happens is the value will keep changing direction. Okay, you have a sine wave, so it will keep changing between +5 and -5, for example. Okay, so how we state the difference here? You just have to say the alternating current, the AC, will reverse direction. Okay, but DC, direct current, only one direction. Okay. Question D. Suggest one advantage of storing energy in a large rechargeable battery. Okay, so we already have a solar panel, but why we still need this large rechargeable battery? The answer is because we are too rich. No, okay, so the advantage because this is solar panel, so it cannot function when there's no sun. Okay, that's why we need a battery for backup. Okay, so this one, so that electricity can be used when there is no sun. Okay, so by the way, you guys know how to answer your son when your son asks you what is solar eclipse? You tell him no sun. Anyway, question E. Calculate the charge that flows in the battery, blah blah blah. So charge formula, Q equals to IT. Okay, so the current is 4. The time, please remember, always change to the standard unit. Okay, so for time, standard unit is seconds. So 2 hours, convert to seconds, 2 times 60 times 60. And we should get the answer, 29,000 coulomb. Easy peasy. Question number 4. Blah blah blah. Calculate the volume of gas when the piston is in its new position. My god, so easy. So this one, the formula is P1V1 equals P2V2. Okay, so the pressure 1 is 1 times 10 power 5. Volume 1 is 240. Pressure 2, 1.4 times power 5. And we need to find the V2. So rearrange this, the V2 is 170 cm3. Done. Number 2, the area of piston, blah blah blah, force exerted. Okay, so this one we have to use the formula P equals to F over A. Okay, to find the force from the pressure. So this one, force when the piston in its new position, so which means I have to use the new position pressure, which is 1.4 times power 5 F over the area. Okay, so type in your calculator, we should get 270 Newton. Mamma mia. Okay. Number 3, the distance moved, average force. Calculate the mechanical work done. So work done formula is force times distance moved. So we just need to put in the values 220 times 0.036 and we get 7.9 joules. Okay. Question B, explain in terms of particles why gases can be compressed but liquids cannot. Oh my god, so easy. Because the particles in liquid, they are touching. Okay, so touching means they are close to each other, so you don't have any space to compress them together. Okay, but particles in gas are far apart. Okay, so there's a lot of gaps between them that you can compress easily. Okay. Number 5. There is a large puddle of water. Describe how evaporation occurs. So easy. Okay guys, so how evaporation occurs is that the more energetic particles on the surface, okay, they escape. Okay, more energetic particles on the surface escape. Okay, number 2, let's explain one change in the weather that causes faster rate of evaporation. My god, so easy. Okay, so one of the change that's possible to cause this happen is higher temperature. Okay, explanation why high temperature causes the evaporation to be faster, because more energy is supplied to the particles. Hell yeah! Question B, a car travels on a dry road, press the brakes, blah blah blah. Okay, then explain how the braking distance change when the road is wet. Oh my god, so easy. So if wet, we know that the friction will be lesser. Okay, friction is lesser. So the braking distance increase. So easy. Okay. Question 6. The speed of wave is lower in B than the A. Draw the graph. Okay, so this drawing of the light wave is simple only. First step, extend this arrow until it touches the boundary. So on the boundary, you draw the normal line. Okay, after you draw normal line, now I know my B is lower speed. So lower speed, your arrow will bend towards the normal. Okay, if faster, then you bend away from normal. So in this question, it's slower, so towards the normal. After that, on the arrow line, you draw the perpendicular straight line, which is your crest. Okay, so for example, like this. And make sure the distance is closer because the wavelength represents your velocity. Okay, the speed reduced, so the wavelength of the wave will reduce as well. And done. Number 2, state the wave effect occurs when they cross the boundary. So easy, this is refraction. Okay, question B1, light can be totally internally reflected, blah blah blah. 2 conditions needed for total internal reflection. First one, the angle of incidence must be greater than the critical angle. So easy. Number 2, the light must travel from denser to less dense medium. Okay, light traveling from denser to less dense medium. Okay, number 2, state 2 advantages of using optical fiber. So why I want to use optical fiber? First, because high transmission rate. Okay, second, they can carry large amount of data. Okay, if you want to write the third one, you can say it is more secure. Okay, because the data, you need to decode it before you can know what's inside. Show AJ. Okay, let's go to number 7. Draw the circuit diagram. Okay, so now we have AC supply with 2 lamps and connected in parallel. So AC supply, you draw 2 circles with a sine wave in between. This is your AC. Okay, and then the lamp is a circle across. Okay, and then we connect the other one in parallel connection. So, done. Easy peasy. Next, EMF, blah blah blah. Calculate the current in the 800 ohm lamp. Okay, so this one just use V equals to IR. So the V is 230. I, the resistance, 800. So we get 0.29 ampere. Done. Number 2, calculate the energy used in 5 hours. Give your answer in kilowatt hour. Oh, okay. So, okay, this one we have to use the. Let's find the power first. P equals to VI. And what's my V again? 230. And the current 0.29. So we should get the answer 6.767 watt. Okay, and I convert to kilowatt divided by 1000 is 0.0667 kilowatt. So now we need to look for the answer in kilowatt hour. So we just need to use this kilowatt times 5 hours. Okay, and we should get answer 0.33 kilowatt hour. Done. So easy. Okay, number 3, calculate the combined resistance of the 2 lamps. So parallel connection, the resistance you have to find with this formula, 1 over R equals 1 over R1 plus 1 over R2. So we have 1 over 800 plus 1 over 1200, and we should get the answer 1 over 480. Then the final step, don't forget to flip it back. So R is equals 480. Oh, done. Okay. Now question 8. State what is meant by magnetic field. So magnetic field is the region which the magnetic poles experience force. Done. Okay, question 8. We have a car here. Blah blah blah. Okay, the plastic cylinder does not affect. State why there is a lower maximum speed when the trolley travels from left back to the right side. Okay, so this one of the reasons you can say is the friction between the trolley and the track. So easy. And 2, as the trolley enters the coin, move from the right to the left, deflects 0, blah blah, moving back from left to the right. Okay, so this one what happens is the direction is still the same. Okay, direction is still the same because you can see the poles on the magnet going in is north here, but when we go back is south going in this direction. Okay, so your current only move in one direction, so direction still the same, or still to the left. Okay, but your speed is lower. So speed lower, the current produced will be smaller value, so there will be smaller deflection on your ammeter. Okay, so why smaller deflection? Because the cutting of your magnetic field, okay, is slower rate because your car is moving slower. So here, smaller rate of change of the magnetic field. So smaller current is induced. So easy. Next, number 9. Ooh, radioactive. So the beam enters the region where there's a strong blah blah blah. Draw and label the path within the magnetic field of alpha particle. Okay, so this one, how to do it? You have to use this hand sign. Remember this? Fleming's left hand rule. Okay, so the thumb is your force, the F. Okay, the index finger is your B, magnetic field, and middle finger, current, so FBI. Okay, so your B, this one magnetic field is going into the page. So your index finger, you point towards the paper. Okay, towards the cross, and then your current is same as your alpha. Okay, so this one is moving to the right, so my middle finger points to the right, and you see your thumb is going upwards. So I know my alpha will go upwards. So easy. The gamma is always straight line, okay, because gamma got no charge. And your beta will be opposite of your alpha, and it will deflect more because the electrons is lighter. So yeah, you're done. Easy peasy. Okay. And then the next one, we have a table, define the half-life. Okay, so what's half-life? Half-life is the time taken for the nuclide to decay to half. Okay, the nuclide decay into half of its original value. So AJ. And then the next one, aluminum sheet, the radiation, experimental radioactive source, most suitable, blah blah blah. Okay, so the most suitable radioactive source for this will be which one? PQRST. Answer will be R. Okay. So why we want to use R? Because this one, the half-life, okay, you can see is quite long, 29 years. Okay, why we don't use too short? Because if your half-life is too short, you have to keep maintaining your machine, so it's not that good. Okay, so first one, you say the half-life is long. Okay, half-life is long. And next, wait, so why we need half-life is long? Okay, so the source don't have to be replaced too often. Okay, like I said, we don't want to keep maintaining the machine. Okay, we want to save the cost. And the next one, okay, you can see is beta. Okay, so remember penetrating power, beta can be stopped by the metal. Okay, so you can use alpha because alpha, they totally cannot pass through the aluminum sheet. And gamma is too penetrating. Okay, so the best one is beta. Okay, so here, okay, let's explain. Gamma cannot be stopped by the aluminum sheet. Okay, and the alpha, okay, will be totally absorbed by the aluminum sheet. Okay, so the beta is the only one which can change current rate. Okay, based on the thickness of your aluminum. Beta is the only one. Okay, we change the count rate. Okay, with the thickness of the aluminum. So easy, done. Okay, so now question number 10. Blah blah blah. The planet nearest to the sun are small and rocky. So easy. The planet furthest from the sun are large and gaseous. Okay, so all the planets will form when the cloud blah blah due to gravitational force. Okay, they will pull together to form the star. Okay, the rotation of a material in the cloud forms an accretion disk. Okay, accretion disk is when they start rotating. Okay, they will form like a disc shape. Okay, question B, time taken 1.3 seconds, find the distance. So this one's easy peasy. Speed equals distance over time, so distance is speed times time. So the light speed is 3 times 10 power of 8, and the time taken 1.3 seconds, so we get 3.9 times 10 power of 8 meters. Done. Okay, question C, Whirlpool galaxy this much light years, Hubble constant, calculate the speed, blah blah blah. So Hubble constant formula is equals to V over D. Okay, so now we're looking for the velocity, the speed. So we use Hubble constant times the distance. Okay, so Hubble constant 2.2 10 power of -8. The distance. Okay, this one is given in light years. So I'm going to convert this light years into meters. We have to multiply 9.5 times 10 power of 15 meters. Okay, 1 light year is equals 9.5 times 10 power of 15 meters. Please memorize this value, okay? Then the next one, okay, we just do it in calculator and you should get a final answer. 4.8 times 10 power of 5 meter per second. Done. So easy. Okay, so that's all for this paper. Hope you guys enjoy my teaching, and please like and share my video and subscribe to my channel. Thanks for your support. Happy studying. Hope you guys got a star in your IG exam. Ooh la la. Goodbye guys.